This is Anil. Today we are going to learn about Nernst equation. What is this Nernst equation? Nernst equation gives the quantitative relationship between concentration of metal ion or non-metal ion and electrode potential, or in simple words we can say that by using Nernst equation it is possible to calculate the electrode potential of any electrode at a given concentration. I repeat, by using Nernst equation it is easy to calculate the concentration of any electrode at a given concentration. You may have a doubt, what is electrode potential? Let us see a simple example. If I have taken a zinc rod and I place that zinc rod in zinc sulphate solution, then what happens, electrons transfer takes place from zinc rod to zinc sulphate solution. In common, I can say that whenever a metal rod is placed in its solution, there may be a transfer of electrons from metal rod to its solution, or there may be a transfer of electrons from solution to the metal rod. In electrochemistry, we call this metal rod as a electrode, and the salt solution is called as a electrolyte. Because of this transfer of electrons, a potential difference is developed between electrode and electrolyte, which is called as a electrode potential. Electrode potential is the potential difference developed between electrode and electrolyte. This electrode potential at any concentration can be calculated by using Nernst equation. Nernst equation can be written as E is equal to E naught plus RT by NF into ln metal ion concentration or electrode in its ion concentration divided by electrode in the or metal in the given concentration. E is equal to E naught plus RT by NF into ln Mn plus concentration by M concentration. Instead of ln, I can rewrite this equation in the form of log. So I can rewrite the equation as E is equal to E naught plus 2.303 RT by NF log M plus N concentration by M concentration. Let us try to elaborate these symbols. What is E? E is electrode potential at given concentration. What is E naught? E naught is a standard electrode potential. R is universal gas constant. T, temperature in Kelvin scale. N, number of electrons transferred. F, Faraday. 1 Faraday is equal to 96,500 coulombs. As I had already mentioned, what is M plus N and M. When we substitute the value of R, that is 8.314, value of T, 298 Kelvin, value of F, that is 96,500 coulomb. In the above equation, I get the value as E is equal to E naught plus 0.059 by N into log of metal ion concentration by metal concentration. Let us apply this Nernst equation to different electrodes and let us see how this equation changes in different forms. Now, let us apply this Nernst equation for a single electrode of zinc rod placed in zinc sulphate solution. So, we can write the equation as E Zn by Zn plus 2 is equal to E naught Zn by Zn plus 2 plus 0.059 by 2 into log of Zn plus 2 concentration. You may have a doubt why I have written 2 here and why I neglected this concentration of the metal. See, here whenever there is if you see the equation carefully, the zinc is transferred into Zn plus 2. That means in this process 2 electrons are lost by zinc. The number of electrons transferred during this process is indicated by the letter N. Then, why I neglected the concentration of the electrode? Whenever the electrode is present in the solid state, then we have to consider the concentration of the electrode as a unity. Whenever the electrode is present in the liquid state, of course, we will consider and we are going to express in terms of moles per liter. When the electrode is present in the liquid state. When the electrode is present in the gaseous state, then we are going to express its quantity in terms of either bars or in terms of atmosphere. Now, let us try to apply for this Nernst equation for a standard hydrogen electrode. When we apply this equation for standard hydrogen electrode, E is equal to E naught plus 0.059 by N into log of metal ion concentration by metal concentration. For standard hydrogen electrode, we can write the equation as H2 comma Pt by H plus. Here in this process, we can see there is only one electron transfer takes place. So Nernst equation can be rewritten as E is equal to E naught plus 0.059 by 1 into log of H plus concentration. Again, why I have written 1 here? Because there is only one electron transfer takes place. So I have written as 1. Then why I have neglected the concentration of metal? Because in case of standard hydrogen electrode, the concentration of the hydrogen, here you can observe carefully, here hydrogen is present in the gaseous state. So whenever hydrogen is present in the gaseous state, I have to consider this concentration of the electrode in terms of atmosphere. I have to express its concentration in terms of atmosphere. For standard hydrogen electrode, the pressure is taken as 1 atmosphere. So when if we write 1 or no, if I didn't write 1, nothing differs. Then I also know that the standard electrode potential of hydrogen is 0. So when I substitute that, then I can write the equation as E is equal to 0.059 into log of H plus. Take the negative sign on both sides. Therefore, minus E is equal to minus bring this 0.059 to this side, then E by 0.059 is equal to log of H plus. Take negative sign on both sides, then minus E by 0.059 is equal to minus log H plus. Negative logarithm of H plus concentration is nothing but pH. So therefore, pH is equal to minus E by 0.059. Very important formula. That means if you know the electrode potential, it is possible to calculate the pH. If you know the pH, it is possible to calculate the electrode potential. Then we will continue. Now let us see this example. The potential of hydrogen electrode at pH 10 is. That means you are supposed to calculate the electrode potential at a pH of 10. We know the formula. pH is equal to minus E by 0.05. Substitute. Instead of pH, I can write 10 is equal to minus E by 0.059, or E is equal to minus E is equal to 10 into 0.059, or E is equal to minus 0.59 volts. That's it. Thank you very much.